we're changing their algal communities for a more heat-resistant algae. So when they're actually outplanted, they can survive. Yay!
Congratulations, little creatures.
And provide homes for fishies like Nemo and Dory.
Yep, exactly.
Dory.
So,
Are you serious?
Yes.
Dory is alive.
Do you know something about corals?
No.
I know something about corals.
I know how to spell corals.
I know that they can live for like a really, really long time. I know that like they like feel, right? Like they have nerves. Like they have nerves, right? Like they can feel.
They have chemical sensors. Hi guys, welcome. I just started, so you're not missing much. I basically just said that we're changing the algal communities within a coral. So
Come on.
a more
I'm recording. I'm gonna put this on YouTube.
outplanted back onto the coral reef.
I'm gonna get some followers.
Surviving. So what we're doing here is we're purposely stressing out coral and a very important relationship between coral. Come on in, guys. Come on in. I'm just going to try to get everybody in here at the same time. Come on in. Keep on in. Welcome, welcome.
Well, that's mean. We want to stretch the little corals
So
out.
this is our lab in residence. Right here we're dealing with corals and their algal communities. So we're trying to change their algal communities for a more heat-resistant algae. So when they're outplanted back onto the coral reef, they can actually survive. Big deal, okay? Huge deal. So come in, guys. Come on. Welcome, welcome. Enjoy your visit, guys. Thank you.
Thank you.
Now that I've got everyone's attention. So corals and algae have a very, very important relationship, and they have worked together for millions of years. It's all worked out just great. You know, the ideal temperatures, the ideal light, and they've grown tremendously. Like there's corals that live at the bottom of the ocean. There's corals that live in shallow reef systems. Now this coral here,
That's a
is only
coral?
about the size of my head. Guess how old it is? Any guesses?
2 million.
No, not that old. Guess.
2 years old.
I wish this was
200?
2 years. Oh gosh.
50
guys.
years?
This is 40 years old.
Oh,
40? That thing is giant.
How do you tell the age? How do you tell the age on them?
It's got rings, just like a tree. And if I was a biologist, I could count them, but I'm not. So you guys can feel this if you want. It's called brain coral.
I knew it. I was
Or
going to
also
say that.
it's called maize coral. Now this is made out of calcium carbonate.
Wow, it's
This
in
is what the
dark.
algae helps the coral build. Now this algae, which gives the coral
It has
color,
like a sort
it's
of
brown
powder
pigment.
on it.
Very, very
It's hard.
Hard.
It's hard like a
The
rock.
algae up to,
Yeah, but it feels like
98% of its
hard.
food just by being an algae.
I'm gonna fill it.
So that's a lot.
You should come fill it.
Mommy.
Now that, come in guys, come on. There's actually another experiment on this side of the room. Do you want to catch it before you come back over here?
Let's cast. Mommy, let's go to that.
No, let's finish what she's saying.
We're exchanging the algal community, and we can't exchange the algae if there's no place for the new algae to go. So we have purposely stressed out this coral, which means now that the algae that gives it phosphate sugars, builds up its calcium carbonate skeleton, is now releasing toxins. And the coral realizes, hey, my partner isn't being a good tenant anymore, so they kick it out. So it's really complicated. We're not sure if the algae leaves first or the coral kicks them out. We don't really know. But I say the coral kicks them out because I will. So that's what leaves its white color. On this side you can tell, and on the far side over here, that they're a little bit patchy. They're not as brown as these corals here. And so what we did is we have risen these coral stands up and put this light down. So we've stressed them out with light. Now we would have done it with water, but we can't control the temperature of the ocean, so there's no point. Because if we could, then we wouldn't have this problem. But
Why
so
couldn't you just bring a bucket of the ocean with you?
because it won't stay the same temperature. So we've stressed out these corals, and so they have expelled their algae. And we've implemented these other corals that's already been through the stress hardening practice, and we've implemented them in the same tank. So it's kind of like encouragement, you know. So hopefully that these corals will now accept this this new algae that's more heat resistant. So when it's outplanted back onto the coral reef, it actually has a chance of surviving. Any questions? I know I just threw a lot at you.
How long is corals live?
Corals can live for millions of years.
Thank you.
Under the ideal conditions. You're welcome, guys. Enjoy your visit.
I have a question.
Hi, guys. Come in, come in.
I have a question. Are those corals still alive?
Yeah, of course they're still alive. These guys are well alive.
Are they
Why
soft when they're in that water? Or
No, they're hard.
hard too?
Why are there rocks in there?
Well, they're there because they've already been through this process, and they're here for encouragement. See, they feel exactly like this underwater. Hi, guys. Welcome.
That's a real one?
But what about-
Yeah.
Did, but did.
Yeah, it's dead.
But what about the ones out there that's like moves with the ocean?
Those are soft corals. So we're working with hard corals and soft corals.
Well, where's the soft ones?
They're gone.
No.
They're dead?
No.
They're alive.
Excuse me.
Questions?
Yeah, I do. I do.
Um,
The little one. The little one. What is the difference between those and the tall ones? That one, that was a pretty one.
Well, this is called Greater Star, and this one's called Lesser Star. And they're just, they're called boulder corals, where they grow on rocks instead of these that branch out.
And those ones are soft, right?
No, well, I mean, yeah, they have like soft tentacles, but they're hard coral. And,
so those are the ones that like
And
reach out
they
and
have-
grab the things?
yeah, and
Oh,
they've been through the stress hardening process already, so they're kind of here as encouragement.
What do you mean as encouragement again?
So
They kicked them out.
enjoy your visit. Thank you.
They kick them out.
So
They
these
come
guys
out.
have already been through this process. That means that they already have the algae that we want. So if we put them
Back
inside a tank that has free space for their algae to like occupy,
Adapt.
we hope
Adapt
that
more.
it would encourage the algae to take up on the staghorn.
I see. Thank you.
What's in there? Oh, interesting. Let's catch the other
So
one.
had algae grows in there. Gotta
You want to
clean it
catch
out.
that one too?
Yeah.
So I don't need algae.
This is very experimenting.
Faded out, but cadmium is another
Just started this one.
And how far do you go to get them? Do you go and get them? Where do they come from? Where do they come from?
Oh, they come from the
Oh, the moms back there, yeah.
guys.
Okay, we're switching spots.
Okay, well, enjoy. Hi, guys.
Hi there, everyone. How are you? Good to hear. Well, over here on this portion of the lab, we are using
I have a question.
a chemistry technique called spectroscopy, and we're going to view some really cool things about light. So
I
we're
have
gonna
a
start
question.
off- Sure, yes.
Periodic table.
Can I record this and put this on YouTube?
Sure, yes, you can. I think I'm all ready to go. All right. All right, so what we're going to learn about today is something called spectroscopy. Spectroscopy is using the properties of light to help us identify the atoms in a sample. Yes, this is a gummy bear. And what color is it?
Green.
Green, yes. So what we're going to do is we're going to shine this green light through
the
this.
gummy bear.
Yes, what do you think will happen?
It will make light.
We'll make light. Let's see.
The light's gonna go through the gummy bear.
Yeah, gummy bear's gonna light up.
Yeah, very cool. So what color is the gummy bear?
Bright green.
Bright green, yes. So when light passes through an object, it's called transmission. But
I
something
learned that.
different will happen. What if I change the color of the gummy bear? What if it's red? What will happen now?
It's gonna change the color of the gummy bear. It's gonna be orange.
It's gonna be orange. That's a good thought. What color do you think it would be?
Orange?
Orange. Let's see. What color do you see?
Red. I still see red.
Dark red. Yeah, it's not green like last time. So what's actually happening is the color red is absorbing the color green. It's called absorbance.
Oh, I heard that. If you wear black, it will absorb the light more. If you wear white,
it
it'll-
doesn't.
Yeah.
Like,
yeah. For example,
The clear one?
she's not absorbing. No,
she's
like,
repelling
the light
into
is going. The light is bouncing off of you, or it's going through like that, like kind of like that. It's still red.
It's still red. Very good. So
It's
what
still
we're going to do
red.
now is we're actually going to look at the whole spectrum of colors here in this room. I'm going to hand you a little lens. Go ahead and look up towards the light until you see a rainbow.
I did this inside my science class.
Wow,
Yeah.
I see a
We
rainbow.
had like these goggles
I see
things
a
you put your
rainbow.
eye and you could see. Like,
Oh, look,
the
I see
different colors
rainbows.
of light.
My rainbow.
You
I
see a
see
rainbow.
And the
That's very
spectrum,
cool.
the different colors of
Oh, and
light
you can
that are
see it through the
inside.
camera.
That's cool. I am definitely putting this on YouTube.
So these are the different colors of light and like.
Look, CJ, you can see it exactly through the video. I mean, the rainbow
Yeah,
goes through.
that's really cool. So does anyone remember why you're seeing all these different colors right now? Do you know how it happens?
Transmission thingy-majigger.
We got the word transmission. So this is actually a property of light called diffraction. Diffraction right here. So what you're seeing is the light is passing through the lens and it's bending out in different directions. So you can see all the different colors.
That is so cool.
I see that.
Yeah. Has anyone ever seen the back of a CD and you see all those different colors on the back of a
Yeah.
CD? That's the exact same concept. That's also diffraction of light, which is really cool. All right, so we're going to talk about how we use this information in our lab here.
Give her the lenses.
I don't want to take a seat.
Thank
want
you
glasses
very,
like
very
I
much.
want to take
for
a
glass.
seat.
He wants to go to class
Alright.
now.
So what we do here in the lab is we analyze the amount of light given off by the atoms from the periodic
CJ
table.
had that before.
You've seen this
I've
before?
had that in my
Maybe in a
class, yeah.
Yeah, that's awesome. So everything is made up of matter. More specifically, everything is made up of atoms. So whenever you would like to identify the atoms in a sample, what you do is you capture the amount of light given off from the atoms and identify which one it is. Kind of like a chemistry puzzle. Pretty cool, right? Yeah. So what we're doing here
Chemistry.
in the lab, chemistry.
I hate chemistry.
We are looking for specific kinds of compounds. We're looking for carcinogens and also poisons as well.
Karsha, what?
Carcinogens, something that can potentially make us very sick if we're exposed to them for a long
And
time.
poison.
And poison.
That's
Yeah,
the
it could
frog.
be radiation.
That's the frog
Exactly.
you guys have here.
Oh, did you go to see the poison exhibit down
We
there?
need a.
Yeah.
It's down
You
there.
want to see the frogs?
We need to go down there. What it all? The car Jordan.
So let's say that we're looking for some of these carcinogens or poisons in the environment. What we do is we take a sample, and it could be a solid sample like food or a liquid sample like water. We shine a very powerful laser on the sample, and we capture the light in a chamber called a spectrometer. Yeah? Have you seen this before?
Yes.
Very cool. So basically a spectrometer
Isn't
will
that
analyze...
a shoebox?
Isn't it a shoebox? It's a little small for a shoebox, don't you think?
No,
For
that's
babies.
it's for baby shoes.
So once the light goes into the spectrometer, we can analyze the amount of light given off by the atoms and identify what they are and if they're safe or dangerous.
How do you do that?
How do you do that? What we do is we look at graphs. We will look at the intensity of light versus the wavelength of light given off by the atoms. And the wavelength of light is going to match up to one of the elements on the periodic table. So you're right here, you're looking at the element Na, which is also known as sodium. Sodium. So this is what a spectroscopy graph would look like for the element sodium.
Soda?
Sodium. Maybe you've heard of sodium chloride, which is table salt.
I was just going to say that.
Yep.
That's like one of my favorites.
What? Can I see that real quick?
Have you ever seen a salt shaker on a table before?
Yeah, you
That's
put
it, that's-
table.
Really?
You put salt
Yes.
on a table and then you wait for somebody to lick it. Funny.
So what's really cool about this experiment is we're opening up the lab later to the public later on in the summer. You can bring us whatever samples you'd like, whether it be a solid, liquid, or later on we can even do gases, and we can
Even a
analyze
gummy
it here.
bear?
Even a gummy bear, yep, we can figure out.
Today?
Today, later on in the
the
summer,
summer.
so in about a month, or so.
Mommy, you gotta bring us here in about a month.
So all those announcements will be made through the Frost Science website under Inventors Lab. Inventors Lab. Yep. And we'll be running this experiment through the end of the year, and we're ready to see. I did not make this TV, no, but it's a great way to look at all these cool things.
Isn't that from the TV?
Isn't this from? Is this from
Like from the inside of a TV? You know
This
that
actually,
they have this big old...
Spectroscope?
this actually is not. This is a demonstration that we use to demonstrate the reflection of light.
Is that a pig in there?
It
For
is a
real?
pig. It is a pig. So what we're going to see here is if you look on the surface of the
It
saucer
looks like
right
it's
here.
popping out.
Yeah, so
Oh,
you
it's
can
3D.
use one.
Hold on,
one
let me get
finger
that.
To try
Let
to
me
pet
get
the
that.
pig.
What?
Let him get it on his
camera thing.
So one at a time, you can actually use one finger to try to pet the pig, and it doesn't work.
It's at 3D.
I want to pet the pig.
Oh, like this is freaky.
Pig, what do you? Where can you buy that?
Cool.
Really cool. Yeah.
So that's how they usually do the 3D picture.
Look, I'm trying to touch it.
Yeah.
Good piggy.
I know for holograms
Can you
in
pick out the
particular, it has to do
pig?
with the bending of light from multiple different directions.
That's cool. That's
Pig.
awesome.
Look.
Yes, it's a kit called
I stick my hand
Mirage
through the pig.
Image.
It's not out.
I will
3D life. That is 3D life. I want glasses like that. For real.
Yeah, that is cool.
What is that thing?
If you're interested in that image, this is the kit you would buy. It's just called Mirage.
Can I have it?
Yeah, of
This
course.
one has to live here in the
Yeah.
lab, but this is something that you could absolutely look for.
Where can you buy it at?
I would say sometimes we get a lot of our supplies from Amazon, actually. It's a good place to start, or they'll at least give you a link to other cool optics places. you
With
could go
that, I'm
to.
sure we can
So
downline and
as
figure it
Star Wars,
Yeah.
they make the holograms as like they get the people inside like this giant capsule inside of the room. And like
Yeah.
they have the people standing in there and like they push their hand through and they use like special effects.
That's what they do in Star Wars.
Awesome.
Matter of fact, we got Star Wars today. Thank you.
My pleasure.
That's
You're the
exactly
bomb.
what they do in Star Wars.
She's awesome, ladies and gentlemen. YouTube, Instagram, everybody.
See you later.
This is going on YouTube, not Instagram.
Oh, well, YouTube.
Bye, guys. Enjoy
Thank
your
you.
stay.
Stay safe in this coral place.
Curl Hospital.
Stay safe, Colin.
They're like making clones of coral.
Where we're going at?
Now we're going.
To the next.
Yes,
We've
we're
been.
going to the poison now.
Yes, poison's on the 3rd floor.
We're going to the 3rd, and then we're going to the 2nd, and then we're going to
To
the
the
1st.
1st, and then where we're gonna go?
We're gonna stay. We're gonna come back up here.
And play with those toy
Not up, all the way
thingies.
back up here, but up here.
No, you said we was gonna go back down there
Up
to
here
play with
where
the.
yes, with water and the sharks and stuff.
Not that. Where's the thing where we played with the toy stuff?
Yeah, okay. That's on the same floor.
Molecules, whatever you call them.
So thirsty all the time.
I don't think I got that.
Yeah, they have a lot of. They have those.
Is
jellyfish
that
here.
a jellyfish pee-pee?
No, don't talk like that.
That's what it looks like. Wow, it's so bright. That's where we're going. We're going to get started there. Come on, let's go.
Yeah.
Let's go, bro. There's one opening right there.
I'm gonna go to the bayside, take a picture of that so you can find one, and then take it here and see if they can identify it. That'd be sick.
Oh,
Wow.
wow. We're going down, Mommy, not up. You're clicking up. We're going
It's
down.
all right. When it gets here, we'll just push down.
Hey, yo, bro, what's up? Can you take it down, please? Please, you down. Oh, it's way
Maybe only one can go up and down at a time.
Why?
Okay.
Thank you. That one was packed, wasn't it?
Yeah, I guess everybody get off. Let me get the good view.
Don't use all your batteries, son.
I only have 27.
And you're still videoing?
Yes.
Where's your time? I don't see no time. 20 minutes.
19 minutes.
Oh.
My total I could get is 25
What floor?
minutes.
Is that?
This the
What floor is it?
Going down. Hello, excuse us.
Fine.
Excuse us.
This is 4?
Yeah, going down.
Yeah, we're going to 3.
tree. Click tree.
3.
Tree. I click tree.
Throwing a whole bunch of fish in there.
Why you guys throwing fish in there for? Like you want the sharks to eat you up.
You didn't throw them in.
We should have been there. I gotta get this view though. Oh my gosh, I feel so woozy in here. Open sesame. Oh, there's a tree. This is not the place to get in the poison. Wow, that's so cool. Another crab in there. What is that? Let's go inside of there. Oh no, we can't. Can we? Not this
I don't know if you can or not.
No, that's where the people go at.
Let's go see.
We can't. No, because what if we get in trouble? Then what?
What is in there?
People. Live. People. See, look, they're in the car. This is poison right here. No, I can't get in here. I told you.
Go ahead. Alexis, let me go first. Thank you.
Oh, I can't get it. See, they look cool with that on. Wow, this is a good place to record. After this 25 minutes and 2 seconds, I'm going live. I am going live. I'm going to get all the viewers. Whoa.
See him shaking his hat?
Are those thingies moving?
Oh, yo, it's an island. Mom, this shows you. So this is sand, right? And you can move
Put it all over here.
And it shows you where it's hot and where it's cold, where all the heat where the heat will mostly hit at, or grass. Oh, this is sick.
Look at your hand.
Look. Look at my hand. It's hot.
Oh, this sand is awesome. It doesn't even stick to you.
But it sticks together.
Mom, you can buy this on. Mom, you can buy this.
I bought you guys this before.
No.
It ended up everywhere.
No, you bought the water one. This is the air one. Look at my hand.
Guys, there's a projector up there.
Okay, guys. Mommy's gonna take a picture first.
Mommy. Over here. Why you took my stuff? Make a big
I
tower.
can play with this all day.
I wonder where you could buy this at. Thomas, make it to a big tower. Oh, it's hot right here, CJ. CJ, stop, it's hot.
Alexis. Hold here. Guys, smile for mommy.
I'm almost out of minutes, Mom. I'm about to end this video and go live, okay, Mom? I'm going live, y'all. Go check.